So first, just a big overview. We have talked about this idea that dietary fat is hydrophobic and it doesn't want to mix with our hydrophilic body. Our enzymes, our digestive enzymes, function in a hydrophilic environment, and so we need to figure out some kind of way to get our hydrophobic dietary fat in close proximity to our hydrophilic water-loving enzymes so that they can actually digest the fat. We don't want to have a situation where we have unmixed salad dressing in our body, because that's essentially what would happen is all the fat within our diet would just kind of float along the top, and then the heavier water would be on the bottom. So that is no way to digest and absorb fat. We need to have other mechanisms. And so we'll talk about how we have evolved to digest and absorb fat from our diet. So let's talk through where some of this digestion is taking place. So we will start off in the mouth. We have an enzyme called lingual lipase in our saliva, so it will have a little bit of digestion that will occur in our mouth, no absorption. Then we get to the stomach. In the stomach, we have another enzyme called gastric lipase. Gastric lipase can also start to digest some of our fat, but it's still a pretty small proportion of digestion that occurs in the stomach. Then we get to the small intestine, and that is where we have about 95% of the digestion of our fat occurring. And this is through a nice enzyme cocktail that we get from the pancreas, as well as we have some other accessory organs that are going to provide some fluid that is going to help emulsify our fats, and that fluid is called bile, produced by the liver. And then we will still have some fat that gets into the colon, and at that point that's due to fat that's typically trapped in the intestine due to fiber, and so as well as some unabsorbed cholesterol, and so those will all end up getting excreted into the feces. Throughout this mini lecture, we're going to use a few acronyms, so I want to introduce them here so you're familiar. So when I'm talking about triglycerides or triacylglycerols, I'm going to use this term TAG, T-A-G. When I'm talking about a diacylglycerol, so that's a triglyceride that has only two fatty acid tails left. One of them has been digested off. That would be, I'm going to abbreviate that as DAG. And then MAG is a monoacylglycerol, and that's when we have our glycerol backbone, but only one fatty acid tail left on it. And then when we have just the fatty acid tails all by themselves, those can be abbreviated as NEFA for non-esterified fatty acid, or sometimes just FA for fatty acid. Okay, cholesterol, I will abbreviate cholesterol as C. Then we can also have cholesterol with a little fatty acid hydrocarbon, or with a hydrocarbon tail attached to it, so that would be a cholesterol ester. And then we have phospholipids, phosphate head with two fatty acid tails. In the digestion process, we will also end up generating some lysophospholipids, which are phospholipids that have only one fatty acid tail. And so these I will abbreviate like this, lyso-PL. Okay, let's jump into digestion. So I have alluded already that we will have a little bit of digestion that goes on in the mouth and the stomach, but not a lot. So first, let's look at what is it that we're eating. The fat that's coming in from our diet is primarily triglycerides. So we have this TAG really big because most of the fat that we're eating is in the triglyceride form. We will be eating some phospholipids, some cholesterol esters, some phytosterols. And then from there, when we eat the fat from our diet, we will have a little bit of digestion taking place in the mouth through lingual lipase. And then the bolus will travel down into the stomach. In the stomach, we have the enzyme gastric lipase, which is secreted by chief cells in the stomach. Remember that the stomach is a very acidic environment, very low pH. So this gastric lipase can specifically function in this very acidic environment. Now, how are we going to mix our fat along and get it in contact with our hydrophilic gastric lipase? That's through churning. So you could kind of think of it like shaking your salad dressing. You're mixing it together, and that's going to allow the gastric lipase to have a little bit of access to the triglycerides and start to digest off one of the fatty acids. And so the gastric lipase is going to start with a triglyceride, and it will digest one of the fatty acid tails off and leaving us with some diacylglycerides. The gastric lipase has preference for some short and medium chain fatty acids. So those would be fatty acids that are 14 carbons or shorter. And only about 10 to 30% of the triglycerides that are in the stomach will end up getting digested. And remember, they're only partially digested. They're still in this diacylglycerol format. And so far, there is no absorption of any of our dietary fat yet. Okay, now let's get into the intestine. That's where the real action takes place. So once we have some partially hydrolyzed chyme that is entering into the duodenum, that is when we are going to stimulate some hormones that will help get our intestine ready to go to digest the fat. So when we have some undigested chyme entering the duodenum, that is going to stimulate the enteroendocrine cells to start secreting the hormone cholecystokinin, CCK. We have been introduced to CCK earlier in the semester, but I will remind you that CCK stimulates many things. CCK is going to stimulate the pancreas to secrete its cocktail of enzymes into the duodenum. And so in this case, we're particularly interested in the enzymes that are responsible for digesting fat, but of course there are also the enzymes in there that are responsible for digesting carbohydrates as well as proteins. The other component of this pancreatic cocktail is bicarbonate, and that bicarbonate again is going to help buffer and bring the pH up because we're getting chyme coming in from the stomach, which is very acidic. So we need to bring the pH up, make it less acidic so that our enzymes can function, and the bicarbonate from the pancreas is going to help us do that. CCK is also going to go and stimulate the gallbladder to start contracting. And when the gallbladder contracts, it's going to secrete bile into the duodenum. And that bile is going to be very helpful for helping us to emulsify our fats during this digestion process. CCK is also going to stimulate the liver to make more bile. Remember that the liver, the hepatocytes, are responsible for making the bile. The gallbladder just stores the bile so that it's ready to go. And then finally, CCK is going to slow down gastric emptying, and that's going to help make sure that we're not overwhelming the small intestine with lots and lots of chyme all at once. So CCK will slow down gastric emptying. So that is how we're going to get started with our lipid digestion.